Hi, my name is Jacqueline Whitaker, and I will be presenting on Chapter 23, Trial and Error. For reference, I am a fourth year second grade teacher. What is trial and error? Trial and error can also be referred to as trial by error. It is a basic method of problem solving, and it's used for fixing something or obtaining knowledge. It's quick and somewhat random, and trials should be guided by theory and thought to minimize errors. The approach of trial and error is solution oriented. When you're using trial and error, you're not taking time to figure out why your solution works. You're just trying to find one that does work. It is also very problem specific. It doesn't relate to other problems. There can be little learning. And it's usually not optimal because you're only trying to find a solution. So when you're trying to figure something out and you get to a solution, then you stop. You're not trying to find the best solution or all of them or what works best. You're just trying to find a solution in most cases. As you can tell from the definition of trial and error, there are a lot of problems with trial and error. The text cautions that trial and error should be used as a last resort to problem solving, and it gives these reasons. It can be very tedious, it can be time consuming, and along with that, it can be very expensive and wasteful. And there can also be risk if one is not experienced. It can produce risky results. This cartoon was in the book, and I thought it was a funny and very accurate example of trial and error. So these cats are trying to find the cans with tuna, but they can't read, so they're just opening all of the cans. So this is a good example as it shows how tedious this is. They have spent all this time opening these cans. It is time consuming. Not only is it taking a lot of time, but they're wasting these cans, which is expensive, and it's a risky result. How is trial and error used in engineering? I was interested to see how Messler explained trial and error in engineering, as when I was reading the definitions and all of the cautions, I had trouble seeing how it could be used in engineering. So engineering faculty is actually discouraged from advocating or even allowing trial and error due to engineering students having limited experience and learning, especially engineering students who are just starting out in their education. They do not know a lot yet, and it could be dangerous to allow them to use trial and error before they have knowledge. Based on that, trial and error is best used for seasoned engineers. They have a stronger knowledge of what might not work, which could cut down on how tedious, expensive, and time-consuming trial and error would be. But because they're seasoned, they're also less likely to use trial and error or rely on it. Experience helps to guide trials, and using trial and error is a little more justifiable when there is a little knowledge about the subject. But the main point of trial and error is that you aren't using a lot of knowledge, you're just trialing things and making mistakes and trying them again. Also, it mentions guided empiricism, which is being guided by one's experiences. So it's using experiences from the past that you have tried and made mistakes in and trying to make them better. I did find here on the side, this is an Introduction to Engineering college course from Harding University, and it is explaining that the forerunners of engineers, they mainly proceeded by trial and error. I thought this was important to note because it just shows that before there was a lot of knowledge about things, they used trial and error. So it says that they created many marvelous devices, just like this Great Pyramid here. But I couldn't help but think that if they had knowledge, they probably could have created it faster. I'm sure this was very tedious and time-consuming and expensive. So for the classroom applications of trial and error, this was a little more difficult. I at first thought of younger students, preschool, kindergarten, and even younger. I did teach kindergarten for 2 years, and younger students definitely learn by trial and error. Even as babies, learning to crawl and learning how things work, they do it by trial and error. And so I was thinking of examples that I used, like a sink or float experiment. I would not teach things before we did that in kindergarten. They would just try to guess based on the weight whether things would sink or float. And then later in their school years, they learn why things would sink or float. force and motion, making ramps, just see how fast you can make the ramp. And then in their later school years, they would learn how you can make the best ramp and why it works the way it does. Also shadows, a flashlight, and puppet shadows. So things like that. I thought of a lot of uses for that before there is a lot of knowledge about subjects. Young students are using trial and error. Then I tried to think about classroom application for me in second grade. I would want students to be knowing more about sinking and floating and making ramps. We do learn about all of that. And so I wouldn't want them using trial and error. I would want them using knowledge. So in my classroom, I would say trial and error can be used before a unit is taught. So maybe before I teach about a unit on science and force and motion, maybe I would have them make a ramp and use some trial and error. And then we would learn the content and then they could try it again using what they know. It could also be used for teaching growth mindset. And I was thinking of some applications in physical education where there might be some Mission Impossible type scenarios where you work together with a group and use trial and error. So I would be really interested to see how you would use trial and error in your classroom, especially if you teach in higher grade level, and just to see how that would work in your classroom. Thank you so much.